Hello friends, today I'm going to solve LeetCode problem number 2136, earliest possibility of full bloom. And this is a hard problem, but once you understand the problem properly, the solution becomes very easy to form. So let me start with the problem statement. So we are actually given plant time and grow time. So we are planting plants, and we can only plant one plant at a time, but we could overlap the plant time with the grow time, and grow time could also overlap with grow time, but no plant time could overlap with plant time, which means that if you plant one plant at one day, then you couldn't plant this another plant at the same day. But if you are planting one plant at one time, the growth of the other plant could happen at the same time. So this means that we could take two things from this given problem statement. One is that it will take us at least the total number of plant times that is given to us in the question, as no plant times can overlap, right? So if you have these many plant times, then at least the time required to uh, plant all the trees is equals to the sum of all of these. Let me just explain you with an example. So we are given these plant times and we could not overlap. So if I'm planting one plant at day 0, I could not plant the same another plant at the day 0. So I'll plant the another plant at day 1, and then since that plant takes 2 days, I'm planting the second plant at day 1, and then the other plant I will start planting that other plant from the next day. So again it will take me 3 days, of 3, 4 and 5, and to plant the last plant it takes me 2 days. So then I'll start planting it from the next day, and it takes me 6th day and the 7th day. So the total plant time is 7 here. Now the grow time is what we can do from here is, like, we know we could overlap grow time with the plant time, right? So what if we do something like this? If we take a grow time which is longer, so suppose there is a grow time, there is a plant time of suppose 2, and the grow time for that one is suppose 7, and I have something which has a plant time of 3 and the grow time is 2. Suppose we have 2. Now what if I do something like this? So 1 2, okay, let me just write this down. So these are the number of days and these are my values. So if I take this first, that means I have a plant time of 2 days. So I'll plant here and I'll plant on the second day as well, and then the plant starts growing and it takes 7 days. 1 2 3 4 5 6 and 7. So total days it takes is 8. And now to plant the next one and to grow, it takes 3 days to plant and 2 days to grow, and we know we could not plant 2 plants at the same day. So we start from the day when the other plant it starts growing. So I plant the second plant here, and it takes 3 days, 1 2 and 3, and then starts growing from here. So 1 and a 2. So you see, right, while the other plant is growing, my next plant has already been planted and has started to grow and has grown and has bloomed the other day, while this plant is still growing and it only blooms on the 9th day. if I'm gonna do something like, if I plant the this one first and this one second, then what's gonna happen is I plant this on day 0, day 1 and day 2, and then it grows on 0, third day and the fourth day. So this is the fourth day that it grows, and now I plant the other plant which takes 2 days. So I plant this, and now it takes 7 days to grow. So at fourth day I have completed planting, and now 7 days. So you could just do the calculation, right? 4 5 1 2 3 4 2 7. So this is basically 4 plus 7, which is equals to 11. Or I'll just write it for you so that it's easy for you to visualize. 1 2 3 4 5 6 and 7 days. So it takes 7 days to grow. So 4 5 6 7 8 9 10 and 11. So you see, took me 11 days to grow, and then it only blooms in the 12th day. So the benefit of overlapping is you could do multiple tasks at the same time. So that is what we are going to do. So we are going to select the plant first which takes the longest time to grow, so that we have the most number of overlaps, and this will reduce the number of days for all the plants to grow. So in this example here, what I'm going to do is I'm going to take this grow time, and then I sort it from largest to smallest, and we will have to keep a map of which grow time corresponds to which plant time. So 2 corresponds to 1, the other 2 corresponds to 3, and 1 corresponds to 2, and the 1 corresponds to 2. So I plant the first one with grow time 2, it blooms on the third day. Then I plant this one with the growth time of 2, and it takes plant time of 3 with the growth time 2 and blooms on the sixth day. And then I plant this one which takes 2 days to plant. So I start planting by overlapping it with the growth time of the earlier one. It grows on the sixth day, and then it blooms on the seventh day. And then I plant the last one, which takes a plant time of 2 and growth time of 1, and then blooms on the ninth day. So the total number of time it takes is 9. So from here, I guess you know how to proceed with this problem. So first of all, I'm going to create a map. Let me just clear this thing. So I'm going to create a map that would keep track of which growth time corresponds to which plant time, and then I'm going to sort the growth time in descending order, so that the one with the longest growth time is planted first and starts growing, and then I can use that growth time and overlap the plant time of other plants with the growth time of the previous one. So in this way we will get the least number of days. So let me start coding. Okay, something is wrong here. Ah. So what did I do wrong? Next time. So from the growth time, that length. Alright, can I read properties of undefined? Map that gate, grow time, I. Well, I less than grow time dot length. So this will increase, and this is going to check if it's less than length. So if it is less than length, there should be some array, of course. So did I do something wrong here? Grow time, map that has, then array equals to map dot gate, and then push. Okay, and map dot set c comma array. Then here we go. Alright, still j equals to 0, j is less than or dot length, j plus plus, and this should be working fine. What's wrong here? Let me see. New array, j equals to the grow time, map that has c, then we set we get the array value, and then we push to the array the current plant time, and then we set the value of g with the value of the array. Okay, sounds good. And this is what I'm doing, the sorting, and I use less than grow time dot length, let array equals to map dot get grow time I. Okay, and for let j equals to 0, j is less than array dot length j plus plus. So array is undefined. Can read it, properties of undefined. So array here is undefined, and why is it undefined? Because it could not get the value from the map for this one. And why could it not get? I don't know, maybe because I is greater than grow time, which cannot be because there is this while loop, and maybe because I did not push the value for I. Oh yeah, here. I'm such a fool. Sometimes I do so silly mistakes. Like this one. Great, finally. Okay, so the runtime complexity would be, since here is a for loop running once and a for loop again, so it's O of n. The time complexity is O of n, and the space complexity is also O of n because we are using one map. So yeah, that's all. Thank you.